ladies and gentlemen.
So let's talk measures of spread. So we've kind of introduced this idea of data and data sets through our measures of center, but we can also get some insight on data based off of other ideas, specifically how the data is arranged. So the range of a data set is the difference, the distance between the smallest value in the data set and the largest value in the data set. So we essentially find it by taking the largest number and subtracting the smallest number from it. The standard deviation is variation. How spread apart is your data? If the data is really spread apart, it's clumped everywhere, then it has a large standard deviation. The more confined your data is, the closer it is together, the less variation there is, the smaller your standard deviation. So if we have some outliers and we have a lot of data in the middle, there's not going to be as much standard deviation as a more uniform distribution. Finally, the shape of a distribution of data can give us a lot of insights as well. So let's talk about a few different shapes. The first shape we're going to talk about is a uniform distribution. That is where all of our data sets, all of our values appear the same number of times, or roughly the same number of times. And that means that there's a lot of variance in your data. There might not be a whole lot of causality there. So uniform just means there's an even spread of data along from your smallest values to your largest values. A normal distribution is more in line with something that you're more often going to see. It is your nice bell curve. So we have a little bit more, so on and so forth. And then it goes back down. You'll see a bell shape in your data. It's probably not a very good drawing of it. It's probably not a great drawing either, but you see what is referred to as the bell shape. Basically, it means that your data is around the middle, around the average and the median, and the average and the median are both roughly the same number. And there's a lot of cool properties that a normal distribution has. We're not going to go into all of those properties here, but very interesting. A skewed left distribution means that we have a tail, we have outliers on the left. What that means is that our bulk of our data is on the right. So, not quite a bell curve. We have some data sets over here getting into a sort of bell, but not completely symmetrical. We have the left side is dragging it some. One of my former colleagues used to say that means that there's a tail on the left. Kind of like drew a picture of a rat, and the rat tail was on the left. If that kind of makes sense. That's an awful picture. I'm not going to be able to draw it, but you get an idea. A skewed right distribution is the exact opposite, where most of our data is on the right side, but there's some outliers on the right. So we get something like this. Again, you can think of it as we have most of our data on the left, and we have some sort of tail on the right side. The last one we're going to talk about is a bimodal distribution. You could also have a multimodal distribution. What that means is that the average is not going to be where the data is held the most. Your most occurring data, the mode of the data set, is occurring in two separate locations. So you can kind of almost get like an M shape here, if that gives you any idea. So that means that the average and the median could possibly be in the same place. It could be in different places depending on how far away those peaks are from each other and how close they are to the center of the data, but it means that your data is kind of being pulled in two different directions instead of simultaneously towards one particular direction, like the normal skewed left and skewed right. Something I do want to mention is that for the skewed left and skewed right, the median and the average are going to be in different places. For a skewed left distribution, the middle of the data set is going to be different depending on how you view it. For normal, the median, the mean, and the mode are all roughly the same number. Everything's at the peak. But for a skewed left distribution, the median is going to be closer to your middle, where these outliers are going to pull the mean, the average, down. Opposite for a skewed right, the median is going to be where the bulk of your data is, but the average, the mean, is going to be pulled up because of positive outliers, because of outliers above the average, where this has outliers below the average. So the skewed is skewing the mean, the average, where the median is still going to be roughly where the biggest chunk of your data is going to be. All right, time for questions. So we have two questions here, and they're both based off of the same data set. So the table below shows the distribution of grades on a recent calculus exam for two instructors. We have Whaley and King, and we have two different distributions of grades. You can see there's 30 students in each class, and the number of students that got between a 90 and 100 for me was 1, for King was 5, so on and so forth. So we're going to ask some questions based off of this data. Which of the following statements correctly compares the exam results? So the mean score of King's class would be higher than the mean score of Whaley's class. Well, as you can see, mine would be skewed to the left, which means that most of my data is larger. So I have a distribution that's kind of like this, where the King data has a distribution that is more uniform. In fact, it's completely uniform. So this means that my average, or the Whaley average or mean, should be higher, which doesn't correlate with A. The standard deviation of Whaley's class is smaller than the standard deviation of King's class. So you can see that there is less variation in this data here, in the Whaley data, than there is in the King data. The King data is very varied. There's a lot of data in a lot of different places, where for the Whaley data, there's less data in those off-put places. Most of the data is around the 70 to 89 mark. So the standard deviation is smaller for the Whaley class. But let's look at the rest of them. The standard deviation of King's class is smaller. Well, that's the exact opposite of B. So if you ever get a question like that where you're given two options that are just complete opposites, it means that one of them is probably true. The last one, the mean score and standard deviation of the exam scores are the same for the two classes. Well, you can see that the normal distribution should have a mean, an average right in the middle, where this data is skewed up some. So they would have different for the two different classes. And then question 2 is, which of the following statements correctly describes the spread of the data above? The first one is the range of both classes is similar. Well, that's actually true. The data set goes from 40 to 100 for both. There's data for both in each of them. So they both have a range of about 60. We don't know specifically because even these have ranges themselves. There's variance in that. But that looks like a pretty good contender to me. B is King's class is more likely to have an outlier in the data. So an outlier is where we have this tail. So there's a outlier here. These are more outliers than, the rest of the data. But for King's class, there can't really be an outlier because all of the data is uniformly spread. So there's nothing skewing the data one way or the other. So that would be false. Whaley's class would give a more uniform distribution. Well, we already talked about that it's skewed in one direction. We also have 1s and 12s and 13s, so that definitely does not scream uniform to me. And the last one is King's class would give a more skewed distribution. Well, it's not a skewed distribution. It's uniform. So by definition, it cannot be skewed. So that means that A was the right answer there. If you have any questions, please let me know. Otherwise, I look forward to seeing you next video.